Hello, everyone. Welcome back to Gateway FM. I'm Cassie, and today in this podcast, I want to start with a question. Why is it still so hard for blockchains to be fast, private, and actually usable at the same time? This question is why we're having this conversation today. We'll be talking about Miden, a blockchain that came out of Polygon Labs, raised $25 million, led by A16Z, and is trying to rethink how privacy and scalability actually work in practice. But more than the tech, this is really a story about realizing something isn't working and having the courage to rethink the assumptions. I'm really excited to be joined by Bobbin, co-founder and head of technology at Miden. Bobbin, thanks so much for being here.
Excited to be here. Thank you for having me.
Thank you. So before we get into Miden, could you introduce yourself a little bit and share what you do at Miden?
Yeah, so as you mentioned, I'm one of the co-founders. I'm primarily focused right now on like the tech behind Miden to make sure we kind of like build all the right components and go to mainnet in a timely fashion, which we hope to do around late Q1 or early Q2 next year. Overall, like I would say, I'm kind of the architect of Miden, so to say. Like I came up with the original protocol a while back. I'm sure we'll get into the history. But yeah, I'm leading the tech team and overseeing a lot of other aspects as well. And yeah, really excited to talk about it.
Nice. And before Miden existed, what were you working on?
I have like it's an interesting question to answer because in some ways I've been working on Miden like for a long time in different places in different ways. It is a project that I've kind of like you can say working for the last 6 years or so. It just like it wasn't always called Miden, and it wasn't always in a separate company. It was like as part of something else. But the idea has always been the same. So if I go back to let's say 6 or 7 years ago when I first learned about blockchains, I was super excited about the tech itself, like the blockchains. Like once I learned what it can do, like being able to send like value assets like money or whatever without intermediaries, like that was a very powerful concept, as well as like the idea of that you are in control of like your own assets because nobody can take it away from you without your permission. I come from the background from like I'm originally from Eastern Europe and saw the collapse of USSR where like the people's holding got devalued like basically within a year, like the money that you could use to buy a house became worthless within like a year time span. And so for me, like those things resonated quite well. I did see quite a few problems with the blockchain tech at the time, and that was like, again, 2017, 2018 timeframe. For me, the two problems that really stood out was like the scalability. I remember the first time reading Bitcoin white paper and fully understanding it. I was like, how is this going to work? This is like only 6 transactions per second. Like there is like no way this can become a global global rails for payments, finance, or anything else like at this scale. And the second issue I saw was privacy. I mean, that was kind of mentioned in the Bitcoin white paper, but it was pretty clear early on that like the level of privacy that you can have with Bitcoin, Ethereum, or most other chains that existed at the time, like was not something that is acceptable in the real world. Like we don't accept the state of the world where like your bank account transactions are fully public. And so how is it going to work on chain? And so for me, the quest was really figuring out how to address those two problems. And the last 6 or so years was like basically figuring out how to do this. And in the last 3 or 4 years working on Miden specifically, but even before that, it was kind of like how do I build a tool set to solve those problems?
Okay, nice. So you mentioned so when you read the Bitcoin white paper, that was like moment you realized this is not gonna scale. Are there like other moments that you encountered that you were like, hey, this is broken, like I need to do something about this?
I mean, it was kind of, I would say that like, I don't know if I can place a specific moment, except like I read the Bitcoin white paper and was like, that's not gonna scale was obvious. The privacy aspect took a little bit longer to understand. But once I understood it, I was like even somewhat depressed because again, I loved the idea behind the technology. I didn't see a solution to it. And like this really changed when I learned about ZK proofs, right? Zero knowledge proofs were something that, okay, once I learned that this technology like was even possible for me, it was like clicked. That was like a switch kind of like where, okay, now I know how this could work. I know this is not practical yet. At the time, people thought it was like, super impractical. Zcash was just kind of getting started and, things like that. But it was already a concept of what it could do. And so for me, the question became was like, how do we make zero knowledge proofs more practical so that we can solve these problems of privacy and scalability at the same time?
Got it, got it. And was there like anything you tried before Miden that kind of didn't work?
In the blockchain space or more generally?
General is also
Oh yeah, for
welcome.
sure. I mean, there is like, yeah. I mean, I have a very interesting background. Uh, I started out like in computer science, right? So like I did my degree in computer science, worked kind of in more traditional like Web 2 companies, and then I at some point decided that I don't want to be coding anymore, and so I went to business school, and like after business school went into management consulting, and so spent like 5 years in management consulting, and then
Hmm.
decided that management consulting wasn't as interesting either, and so I started a startup, and that was a more traditional Web 2 startup. I mean, we did well, but not quite as well as I wanted to, and so like we kind of by the end, didn't achieve what I wanted to achieve, and we kind of like wound down the startup, and that was right before I got into the blockchains because I had kind of like the startup was wound down, and I had some time, and so I started learning about like I think 2017 2018 was like the time where blockchains were getting really hot. I mean, it kind of came in and went in waves, right? Like 2013 was for the first wave where it really became kind of like known to the public, general public, and then 2017 was the next wave when it became again like on the forefront of like major news and things like that. And so it caught my eye, and then I kind of
Hmm.
like got really excited by the technology. But yeah, I mean, my first thing, by the way, was not really so much blockchain related. As I mentioned, I wanted to learn about ZK proofs. So like for me, that was like, okay, how can I'm not a cryptographer. So like for me, I don't have like PhD in math or anything of that sort. So for me, it was like, okay, can I build like a proving system by like imitating somebody? And at the time, which was super helpful, Vitalik had a series of blog posts about Starks. And so I read those blog posts, and I basically started building my own Stark prover, which, at the time there wasn't a lot of, obviously Starkware was around already. Ellie and others at Starkware invented Starks as a proving system. But I think kind of a lot of the stuff that they were doing at the time was closed source. So for me, it was like building one of the first open source Stark provers was like a very exciting thing. And I started posting about it on the Ethereum forums and things like that. And so kind of Vitalik noticed it. So like he contacted me, and like I started kind of introduced me to the Ethereum Foundation. So I started working with the Ethereum Foundation, trying to kind of make ZK proofs more accessible to general public. So like at the time, doing ZK proofs was extremely difficult, and especially Starks, because there was a lot of I would say effort going into like other types of ZK proofs like snarks and kind of elliptic curve based proving systems. There wasn't a lot of effort besides Starkware going into Starks, and so I was one of the few people outside of Starkware working on Starks at the time,
Hmm.
and making sure people can actually use it without like having to spend like 6 months or a year just trying to understand the concepts behind it was
Hmm.
something that I was trying to do. So like building ZK focused DSL, so domain specific languages, and then building one of the first ZK virtual machines. That was something I did while still working with the EF. And then after that, I got an opportunity to go to work at Facebook. So Facebook was doing a cryptocurrency at the time. I don't know if
Hmm.
you remember, there was like the Libra
Yeah.
DM project.
Yeah.
And so I worked, I kind of was one of the few people there working on ZK proofs. I mean, there were other people, but I was building the Stark proving system, a really performant one now within Facebook. And it was I was part of the research group. It's funny that a lot of people who like were my colleagues or like I directly worked with are now like part of like SWE and Aptos. So
Hmm.
like it's basically the same. Like people who are founders and co-founders of SWE and Aptos were my direct colleagues in Libra, and that was an awesome project, by the way. Like I really like the concentration of talent there was like extreme, I would say.
Okay.
And so yeah, I kind of continued working on ZK proofs while at Facebook, but after a while, like as basically publicly known now, Facebook was not allowed to launch the DM blockchain not for technical reasons, but for more kind of like regulatory and I would say government-related reasons. And so once it became clear that it's not going to, become a successful project, people started leaving, and I was one of such people. And then, as I mentioned, like the tech was really good, so like it served as a foundation for a number of different companies afterwards. So like Sui and Aptos are the most known ones, but there are others. There's probably like 4 or 5 other companies, like Lightspark is a big one as well, that's more Bitcoin focused, that came out of at least the people that worked on Libra kind of worked on that. So like there's a bunch of different companies came out from that. But after Facebook, I went to work at Polygon. And the interesting thing is that like the things that I built at EF, the things that I built at Facebook, like I kept using them when I went to Polygon. And so it was kind of an evolution of the next step. So initially, like this is, by the way, Polygon was the first time where the name Miden came up. So before that, like there was different names. Like the first virtual machine that I built was called Distaff actually, and then the prover that I built at Facebook was called Winterfell. And then Miden as a name appeared first time when I joined Polygon because we were thinking, okay, like should we reuse some of the previous names? Should we come up with a new name? And so I think Mikhailo from Polygon, who was a co-founder of Polygon at the time, suggested the name Miden, and it kind of like we looked at it and like worked nicely. So it kind of stuck since then. But it basically was a lot of the same tech as I built previously. And like, by the way, one of the things to mention, like all the tech I've always worked in was always open source. So like it wasn't like it was like Ethereum Foundation, obviously everything is open source. There is no like closed source stuff. But even at Facebook, like as part of Libra, everything that we built was open source. And so like using this tech downstream wasn't like an issue at all. Like it was nice that, you kind of build things in one place and then you can continue building on them or using them in different places. And it's a very nice property of Web3, I think, which is relatively, I mean, not exactly unique, but very rare, I would say, in other industries. And so, anyways, so I joined Polygon and worked first like building the ZK virtual machine. So Miden in the beginning was just a virtual machine. There was no blockchain around it or anything of that sort. And then after about a year of working on Miden as a VM, like there's even a post somewhere on GitHub where I first time described the Miden protocol that was maybe like a bit more than a year into this. I said, okay, now that we have the VM, we have enough tools to actually build a blockchain. And so that was the time when kind of the Miden as a protocol came together. And that was, I think, like a bit more than 3 years ago now, something like that. And then so we will basically Miden as a protocol has been work that I've started doing at Polygon about 3 years ago. Throughout that time, I also became one of the co-founders of Polygon. And so, Polygon was and still is a very big company, one of the dominant players in the Web3 space. By the way, one of the reasons I joined Polygon was that I really liked the outlook of like how Polygon thought about the future of blockchains that aligned very well with my personal views, especially in terms of ZK. Like I thought ZK, as I mentioned, like in my mind, that technology that can solve the issues of blockchains. And so that was very nice. And then, a lot of the work on kind of like heavy research and initial development was done over this a couple of years at Polygon. And then earlier this year, we kind of decided to spin Miden out because it made a lot of sense to do it within Polygon while we were building this, but like to bring it to market, I think it's better to do it as an external entity. And obviously, we still have a very, very good relationship with Polygon and all of that stuff. But Miden is, as you said, now a separate entity, and we're working on kind of like the last leg of this journey to get it to like mainnet. I mean, I guess maybe not the last, but there is like a moment to getting to mainnet. I'm sure there's going to be a ton of work after that, but this is going to be pretty exciting, and it's kind of going to be a culmination of like, I would say almost 6 or 7 years of work.
Yeah, totally. Love that how your journey is like actually quite consistent, like working towards like one like kind of similar goal. That's like also quite rare and probably like saved you like a bunch of time and energy as well. So since we've been like talking about Miden and now it's like a separate entity, so just for someone hearing about Miden for like the very first time, how would you describe Miden in simple terms? For example, for someone like that don't live in crypto Twitter or like non-crypto, how would you describe Miden?
Yeah, I think There are probably a couple of ways to do it. If I had to do it for somebody who doesn't know much about crypto, but let's say they've heard about blockchains overall, right? I would say Miden is kind of a blockchain that is we're trying to build it in such a way where we can get blockchain technology adopted on a mass scale. And for this, we need two things, as I mentioned before. We need to have like massive scalability. We need to be able to operate at the level of Visa and beyond, right, or something like that. And some of the more traditional blockchains had trouble with this. Like more recent ones, like the Sui and Aptos, as an example, are able to scale to that level. But the second thing is that we're trying to achieve is privacy. So like Miden is one of the very few blockchains that allows you to actually have real privacy. And being able to combine both privacy and scalability is a unique, not maybe unique, but a very rare combination, because usually privacy means that you have to give up something. So like, again, assuming that people know something about blockchains, like one of the sometimes surprising things is people realize that blockchains typically are not private, right? Like not everybody knows it immediately. Kind of like the default assumption for a regular person is that, okay, I'm doing it on blockchain, nobody can see it. It's all protected by cryptography. That means like it's all encrypted. But the reality is that it's like, yes, it is cryptography, but there is no encryption of any sort in almost for sure in the mainstream blockchains, right? You can argue that maybe Zcash and Monero are like still mainstream and there is like some protection, but at least like if you think about like Ethereum, Bitcoin, Solana, Polygon as well, like the ones that are used by most people, there isn't a lot of like privacy specific features. And so like once people discover that you actually can trace everybody's transaction, that is like sometimes an unpleasant shock that like your transaction history is fully visible. But assuming that people understand that there is like this privacy issue, I think Miden is basically a privacy focused blockchain that is also will allow to scale to the level that we need for mass adoption.
Got it. Nice answer. So what would you say is like the key innovation behind Miden that really makes it different than like other blockchains?
I think there are two primary things. There are more than two, but the two primary things, and one of them I wouldn't say like is Miden specific. The other one is much more Miden specific. The first one is zero knowledge proofs, right? As I mentioned, you need zero knowledge proofs to kind of escape this dilemma that traditional blockchains had, where you have to re-execute every transaction to know that like the ledger is valid, right? Before zero knowledge proofs, that was the only way for blockchains to work. Like you couldn't figure out if you have the right state without executing all the transactions, and because you had to execute all the transactions, that places like two limits on you, right? This means you as somebody who's operating a node needs to execute every single transaction that happened in the world, which is like not scalable, especially if you want this to be like a relatively small power computer, right? If you're not assuming this is going to be running like a cluster of machines or something like that, which again, you need for decentralization purposes to be able to run it on the fairly, commodity hardware, so to say. And the second thing is like to execute all the transactions, you do need to have the inputs to all the transactions, which means there is no privacy. And so traditional blockchains like have this dilemma of like, how do we have verifiability? And they have to do it by re-execution. ZK proofs are extremely important to make like breaking this dilemma. And saying, okay, you don't need to re-execute everything to have to verify the state. So zero knowledge proofs is like the first unlock. The key here is having efficient zero knowledge proofs, right? Kind of zero knowledge proofs have existed for a while. And a while here is like the last 7-8 years they were practical or something like that. So it's not too long of a time. But it's still like a good time frame. But like the unique thing, I don't want to say unique, but one of the specific things to Miden here is that we made ZK proofs practical for the client-side proving, right? Up until recently, and still a lot of VMs, ZK VMs, if you run them, they require like large clusters and a lot of GPUs and all of that stuff. So you can't really do it on user devices. And for the approach that we're taking with Miden to work, you do have to have efficient ZK proofs on the client side. And so Miden VM was built with that in mind. We want to make sure that people can run on their phones, on or laptops and generate ZK proofs in like not in like 2 hours or like even not in 30 seconds, but in under a second, for example. So a lot of work went into making kind of like client-side proving aspect, and we're still not fully there. There's still a lot of optimizations to do, but where it it's actually practical to run ZK proofs in your on your laptop, in your browser, and like with some other additions, you can do it in even in the smartphone, and you can do it in under a couple of seconds. So like you don't like you can get to this property if it takes you 30 seconds to prove a transaction. Like people are not going to wait 30 seconds for a proof to be generated on their phone. This is just not good experience. So this is like, so I would say this is the first major thing that we had to make sure existed, like efficient ZK proofs and specifically on the client side. And not just ZK proofs, I would say, but also like highly programmable. So the ZK virtual machine. I think this is important because like a circuit-specific ZK proofs existed for some time and they were pretty efficient. Like again, Zcash was one of the first ones that built something like you have a specific circuit that can prove like a transaction, but writing smart contracts, it was very, very different. So being able to write smart contracts that are executed in kind of with ZK properties where people don't know, like you're executing basically an arbitrary program and it still is private. That is like only a recent thing, and there are only like a handful of projects that are able to do that right now. I would say, so this is like the first unlock. The second unlock, I would say, we had to reimagine how the state model works in Miden. And it, like, there are different solutions to this, but like the way the state works on Ethereum, for example, you can do like client-side proving for that just because of the design. And like the easiest way to explain it is like, when let's say I send a transaction to you on Ethereum, like when I send funds to you on Ethereum, I have to like acquire a global lock on the entire like system, so to say. I'm transferring like let's say to you, I need to like basically lock your wallet and my wallet at the same time and move funds from decrease balance in my wallet and increase balance in your wallet. Which means by that when I'm doing this transaction, nobody else can do the same because they can't increase balance in your wallet at the same time as I'm increasing. So like I have a lock on your account in a given point in time. This gets even worse with things like ERC20 tokens because an ERC20 token is just basically a giant hash map, right? Where they have ownership records of this account owns this much, USDC, for example, this account owns this much. And anytime somebody needs to update that ledger, they need to lock the entire ledger and say, okay, I'm going to update the state of USDC contract or whatever. And this basically is bad for scalability that forces you to do things sequentially. And so Miden actually reimagines it because we want people to run transactions on the client side, right? So you yourself can execute your transaction and just send the proof to the network. And to do this, you have to allow a different way for the way state is tracked on the blockchain to work. And the way we did it is like we still have accounts like Ethereum, but we also have this concept of nodes that is borrowed from Bitcoin, which is like UTXO-based they're represented as a UTXO set under the hood. And so for me to send something to you, I create a node, like there's a transaction where I create a node. That transaction takes funds out of my account and puts them into a node. And then in a separate transaction, you consume the node. And this separates, my state update from your state update. And that allows me to, first of all, it allows me to send nodes to you at the same time as somebody else is sending nodes to you. And then you can consume all the nodes at the same time. That creates parallelism where a lot of transactions can be executed in parallel. But it also means that I don't really need to know about your state for me to update my state, right? So like I don't need to like increase your balance, and because like to increase your balance, I need to know what your balance is. That's how it usually happens in like a lot of public blockchains. In this case, my state update is separate from your state update, and therefore we can get this both scalability and privacy at the same time. So in Miden, I execute transaction locally, generate a proof, send the proof to the network. The network doesn't need to know about the contents of my account. They just need to know that the ZK proof that I send them is valid. So they don't need to execute my transaction. That is a win for scalability. And they don't also need to know the contents of my account. And that's a win for privacy, so to say. And so you get both of these properties at the same time.
Yeah, super cool. So like when you guys like build this amazing tech and architecture, like did you have any specific use case in mind that like you're trying to specifically solve?
Yeah, I mean, I think I mean, in all honesty, I think almost every use case needs this, but you have to start somewhere. Like,
Yeah.
but to take a step back, like, again, people don't realize how much privacy is needed, especially in blockchain. Like, I frequently hear there is no demand for privacy. There is like, people don't care about privacy. But I think it's kind of like a weird way to phrase it because this is like we are in blockchains like addressing very few use cases right now where people are maybe willing to give up some privacy, and some people don't even understand that they're giving up privacy. And then in some ways, like it's still not as easy to decode, like link your real world identity to like your activity online. All of this is going to change soon, and you basically will end up in a situation where you have AI tools that allow like to trace your history throughout all the all public blockchains. You'll have um, kind of like ability to link the real world identities to blockchain addresses much more easily than you can do now. I mean, you can do it now, it just costs a lot of money, but in the future that will become much easier. And this will just basically become a dystopia where like, anything you didn't done on the blockchain, I type in your, Ethereum address or your Bitcoin address, and it will give me a report saying, okay, this is who you pay, this is where you go, this is like, bids you make, this is what you trade and all of that stuff. And this is just not how, the real world works. Like this is like a mass surveillance tools at that point in time. This is not like freedom, and it's mass surveillance. Like people think it's governments, and governments, I'm sure, will do that as well. But it's just even criminals. Like if like a criminal organization can trace all your activity and know what you do and when and how much money you have and where you keep your money and all of that stuff, like it's much easier for you to become a target. So like.
Yeah.
Underlying, like there's just like everything needs like the world doesn't operate on a public ledger. The world needs privacy to work. Now, where do we start? I think we kind of think about one of the use cases is more kind of like a treasury management and like use cases like financial related use cases. Maybe not so much about trading yet, although trading is also an interesting one. But more about kind of like people need to manage their money on chain. They don't always, like if it's a small company as an example, they need to, let's say they pay contractors, they want to manage payroll, they want to, and a lot of this is, kind of happening right now, but also a lot of this is kind of held back because you don't want necessarily everybody to see how much you pay to whom, your contractors, your partners, and all of that stuff. And, I think this is one of the use cases. I think beyond that, payments is the next, like, it's much more difficult to like solve the payments use case because it's such a massive thing to address. But I do think at some point payments like can't work without privacy. Like I don't necessarily want to know, like every time I go to a coffee shop, like people to know which coffee shop I shop at and how much I pay or who I hire, like, or who hires me and all of that stuff. And so payments will become a big one. And then like, I do think like the things I'm excited about is like ownership or like where you can own like pieces of communities, for example. And this is like already happening with tokens, but now it's fully transparent again. In a longer run, it will become a problem, and so I think privacy is needed there. But also like bringing real world assets like RWAs on chain, stocks, bonds, and even like licenses or property titles and things, or just like general title information. All of this needs privacy, but like you want to start with like the most immediate use case, and then kind of branch out from there. I think one of the things I should mention here is also institutions really need privacy, right? Like we talk a lot with different financial institutions, and for them, like operating in a fully public way is just a non-starter. I think institutions also need compliance. That's another thing. So like there's like a tension here between privacy and compliance. And so one of the things that we're trying to solve is how we can try to have both, but financial institutional use cases as well as treasury management use cases, I think are the ones that are interesting. And then I'm saying use cases, there's like a whole host of different specific aspects of it, but this is kind of an umbrella term that that we're using.
Totally makes sense. So I do agree. Maybe people are like not that big on privacy yet, but people are definitely very concerned about security. So since like a lot of computation are happening on users' device, how do you make sure the network stays safe?
Yeah, so I think there are a couple of aspects to this. Like I think It depends on what you mean by safe. I think in some ways, like the system where you have computation happening on user device is safer for the user because they again, like you don't broadcast to the world how much money you have or like who you're trading with, and that makes your personal experience safer. If you mean safety in terms of the technological sense, I think there is a unique kind of like complication that comes with client-side proving, and that means is that you need to be really sure about in the soundness of the underlying proving system. Because a bug in a transparent chain is, it's bad, but it's detectable, right? As soon as somebody finds a bug and tries to exploit it, everybody else sees that, and that's definitely a plus of the transparent chains. That once a bug is being exploited, like people can actually see it. In a system that is private, that is not the case. If somebody finds a bug and try to exploit it, other people may not realize it until it's too late, because again, the system is private. And so there is a unique challenge of deploying the systems, the privacy preserving systems, where even a single bug could be catastrophic. And so our approach to this has been to do this privacy rollout in a kind of a slow way. So we will go to mainnet without full privacy. And this is one of the major reasons is to prioritize kind of user safety, because we don't yet have full confidence in the underlying proving system. I'm sure there are, kind of bugs and other things that we want to make sure that are fixed. And then, so we will be double checking people's proofs. So initially people will be private against each other, but not against the Miden operator, and we will be a centralized L2 on Ethereum. So it will not be that different from other centralized L2s in the beginning, but you will have the ZK proofs attesting to kind of the correctness of state transitions, but we will see all the transactions. And then as we decentralize and as we kind of gain more confidence in the underlying proving system, and I'm expecting this to take somewhere between 2 and 4 years, maybe around 3 years, we will kind of enable stronger and stronger forms of privacy. And for me, kind of there is no substitute for this battle testedness, where you've been running in production. People have been looking at your code and trying to find bugs, and maybe there are other things that we can do in this time frame, like formal verification of the underlying proving system, of the important kind of constructs in the protocol and the VM itself. Maybe we can even get to a point where there are two independent proving systems proving the same transaction, so that that if one of them has a fault, the other one unlikely to have the fault in the same way. Again, a lot of this is still an area of research of how exactly we will do this, but again, it will, in my mind, it will take some number of years, between 2 and 4 years, as I mentioned, to get to that point. And so we're trying to do it in a slow kind of way, where you don't get absolute privacy right away. You already get something that is drastically better than the current blockchain fully transparent experience, where you get privacy against other users, just not against the operator. And then as we gain more and more confidence in the underlying kind of system and make sure it's safe and secure, we enable higher levels of privacy. And ideally within let's say 3 years down the road, we enable privacy to a level where we as an operator, we don't see it. And also we will be decentralized by that point in time. So it's not just a single operator. It's a network that is running, kind of a decentralized network that is running the protocol.
It's great to hear that you guys are actually super conscious about this and willing to even take things slow, just to protect the users. So you mentioned a lot about the heavily relying on the proving architecture and the infra. Gateway is actually, we are the infra partner for you guys. Can you give us a little bit of description on what role does Gateway play in supporting your proving infra?
Yeah, so I think there are actually a lot of different areas of collaboration with Gateway we're excited about, and I think we've been kind of closely working now, I want to say for 2 or 3 months, maybe even more. And proving aspect is one of these areas. The other aspects is auxiliary integration, for example, if we want to talk about Polygon, or in general, kind of the other things, the other thing that you guys do for us is running the block explorer. So there's a lot of other areas. But if we talk about specific the proving aspect of this, as I mentioned, for every transaction there in Miden, there needs to be a proof. And you have an option to generate a proof locally, or in some cases, local proof generation may not be fast enough. Even though with all the optimizations that we have right now, I can generate a proof very quickly on the laptop, but on the phone, it still could take if I do it in an unoptimized way, it could take up to 30 seconds. We have some ways where it can be brought down to like maybe under 5 seconds. But if you want the proof to happen, let's say in under a second, like the phone is just not powerful. I mean, maybe it will get there within the next 3 to 5 years. But for now, what the solution that we have for this is what we call delegated proving, where you have a proving service running, like managed by Gateway in this case. And the user sends the request to the proving service, and the proving service runs on a large machine like 64-core CPU or with enough memory and all of that stuff, and then they can prove things very fast, like in under a second, half a second, or something like that, and then they return the proof to you. So from the network standpoint, you get kind of the same kind of properties where you don't know if the proof came from Gateway or proof came from the user's device, right? So you just get the proof from the user, but the user is kind of asking for this help from Gateway to generate the proof. There are trade-offs here. So like you would need to give up the privacy to the provider, but I think it's a decent trade-off. Like if you really want at this point, if you want privacy, you do it like locally on a laptop. Or maybe you're willing to wait a little bit of time. If you really want to do the proof very quickly in under a second, you can ask the remote prover or delegated prover to help you, and you give up some privacy to them. But maybe that's okay because it's still way better than giving up the privacy to the entire world, so to say.
Yeah.
And so this is one aspect. And if you imagine like this is running like at like very high TPS. You could imagine like there's like hundreds of transactions per second, or maybe thousands in the future. You do need to generate 1,000 proof per second, and it does mean that there's going to need to be a lot of machines running. And so you guys are very good at managing infrastructure and being able to like do this auto scaling, because sometimes the demand may be low, sometimes it may be high. You don't want to have like 100 machines running all the time. So if there is only a few, like if the demand is low, you can scale this down, and then once the demand is high, you need to split it up and like. So this is like one of the things that we personally don't have a lot of expertise in doing, but you guys have a lot, and this is super helpful. I would say this is one aspect. So this is the user-facing proofs. There is another proving that needs to happen in Miden, which is once you have this user-facing proofs, you want to kind of roll them up into a single proof as quickly as possible as well. And we kind of do this, so first we aggregate proofs into batches, and then these batches get into blocks. And this is now done by the network. And this also needs to happen very quickly. And for this, you can also imagine that it's running locally, and an operator can spin up provers and like do this. But we can also do the same thing with what you guys have. Maybe it's a slightly different pool of provers, so that they, two pools are separate. There's a transaction provers, and then there's like block provers and kind of the aggregators. But this is another set where, let's say there's 100 transactions per second happening. Somebody needs to generate 100 proofs, and then somebody needs to roll the 100 proofs up, and they can delegate this to a separate prover network, so to say, that can do this, or prover pool that can do this very quickly.
Yeah. Thank you for the very thorough explanation. We're really proud to be able to like support you guys. So you already like kind of bragged us a lot. Thank you for that. But I'm just gonna ask you to brag us a little bit more. So why did you choose Gateway as your main infra partner?
I think, there are a couple of reasons. The main reason I would say is that I've known you guys for a while. We've collaborated a lot during Polygon times. So Gateway worked a lot with Polygon. I've known Igor for quite some time personally as well. And I think consistently what stood out to me, even kind of when I was at Polygon, is that you guys have a very strong team that delivers and is able to do things very well. It's one of the, I don't want to say exceptions, but one of the rare occurrences where you guys meet the timelines if you commit to them. It's really nice being able to say, okay, you guys are experts in this, and I don't need to worry about this because I am fully confident that you guys will be able to solve this. I would say, so this kind of knowledge and your reputation and reliability that I've experienced firsthand was one of the major reasons. I think the other reason was that I think you guys have a lot of expertise specifically working with the AG layer, which is one of the things that we need to integrate with. And so having your expertise there was a huge benefit.
So on your blog, you said something pretty broad. So if Bitcoin and Ethereum were designed today, they would look a lot like Miden. So my question is, on a scale from 1 to we are absolutely right, How serious are you about that sentence? And like, what do you think if Satoshi or early Ethereum devs would say if they saw Miden's architecture today?
I would say so. I think there are two answers to this. The first answer is on a conceptual level, and I think there it's like, in my mind, 10 out of 10. Like on a conceptual level, what I mean here is that you do want to have like most computations not to happen in the network itself. You want the users to run the computations. You want the network not to store the state. You want the users to store the state, and in most cases, and I think. It's difficult to argue about like what Satoshi would have done, but Vitalik has said pretty openly that this is like how he thinks things should work, even in Ethereum. It just will be difficult to move Ethereum in that direction. It will take time, but the idea that you should be able to run ZK proofs and add privacy to Ethereum is like not something like it's basically the goal of Ethereum in many ways. I do think it will be extremely difficult to modify. Ethereum is a big ship, and like to change it in a fundamental ways is going to be difficult. But again, like on a conceptual level, that you don't want the network to execute every single transaction, and you don't want to store the state of every single user. I don't think there is any debate that this is like the way the network should work, at least as far as Ethereum and like Bitcoin would work. There are other networks that may argue with this, but like I would say from what I know, this is probably like a 10 out of 10. Now, in the more technical specific details, I would say there is, would they be using the same proving system? Would they be using the same state model? I do think like of Miden as like another way to phrase it is like if Bitcoin and Ethereum had a baby, it would be Miden in some ways, because it like uses properties of both systems. So there's the account-based system of Ethereum merged with like UTXO-based system of Bitcoin. There are other ways to do it. I'm not saying this is like the only way to like design the underlying state model. I do think it like what we have has like unique benefits and properties, but I can imagine other people doing it that way. So in that, I would say maybe like, I don't know, 6 out of 10, maybe 7 out of 10 is like in terms of technological. I do think, for example, Starks are the right proving system. I do think like the hybrid UTXO and account model has like the right set of trade-offs. I do think like the way we handle nullifiers, for example, or the way we do kind of node discovery is like a very good approach. But also, again, on those, like there could be nuances, and different systems could ended up with different choices. But overall, like again, at the conceptual level, it's 10 out of 10. At the more technical level, it's probably like 6 or 7 out of 10.
I love that. I love that. We don't have much time left. I want to jump onto like a lightning round. So I'll ask you some like quick questions, and you give me one sentence answers.
Sure.
All right. So first, on-chain by default or privacy by default?
Privacy by default. I do want to add a nuance there, if I can. It will not be a single sentence, but I think there are a number of ways like people think about privacy. One of the tricky things about privacy is that usually it adds more complexity. And so like saying privacy by default frequently means like a lot more, it's more expensive or more difficult or takes more effort from the user. I do think privacy by default should also mean things that are cheaper and simpler. And this is like how we design Miden, where if you're private, you actually don't, you impose less of a burden on the network, and so your transactions will be also cheaper. So I would even not say like the privacy by default. I would say like the system should have a way where privacy is incentivized. It should be, privacy should be cheaper than the alternatives. You could be public, but privacy should be cheaper. It not should be the default. It should be the cheaper option.
Got it. Got it. Next one, more developers or more institutions? Which is harder to onboard?
I think institutions are harder in some ways, and the reason why is that developers, especially in Web3, are very much willing to experiment. They've been used to working on with tech that is frequently not finished or is work in progress. Institutions are much more like you need to be running in production for a while and without like incidents for an institution to consider you as a reliable partner or a reliable platform, and getting that takes just more effort.
Got it. One thing you wish people understood better about ZK proofs?
I wish I mean, this kind of goes back to my previous. Is like I wish the people understood that ZK proofs is the technology that makes blockchains possible at the mass scale.
Okay, got it. So last question. In 3 words, what do you want Miden to be known for?
Practical and scalable privacy. I think the scalable part is easy to understand. The practical part is an interesting one. We didn't get into it before, but it is one of the things that I actually been thinking a lot. Because if you think about privacy, it's kind of a double-edged sword of sorts. Because on the one hand, it's essential for people to like operate in real world with like as I already talked a lot about, you can't do real world without privacy.
Yeah.
On the other hand, it does make it easy for like criminals and nefarious actors to like evade justice or evade law enforcement and all of that stuff. And so doing absolute privacy, like we know how to do it. And I think it's if we want to give people absolute privacy, that is possible, and like there are good solutions right now. But I do want to figure out a way how we can balance in such a like both concerns where most people get like real privacy, but at the same time it's not as easy for criminals to abuse the protocol. That is a much more difficult question to answer, and I don't know if there are like very specific good answers yet. One of the reasons, by the way, we also want to take time to enable full privacy is that we want to enable this idea of where maybe we can like figure out and like somehow identify like low risk and high risk transactions, and low risk transactions could be fully private, but high risk transactions maybe there is some conditional privacy where I always try to think about like a system that we like cash that we would maybe in some ways we want to emulate, because cash is has very good properties. It is a pretty private system, right? Like if I make a cash payment to you, nobody else really knows that I've paid cash to you. But at the same time, it has this nice property where making relatively small payments, like a few $100 or a few $1,000 or maybe slightly more, making those payments in cash is fully private and very easy. Moving like $100 million in cash or $1 billion in cash is very difficult, and it's not as easy. And the privacy properties of that is also different. Like doing it like by a single person without anybody knowing is like very, very like difficult to move that much money in cash.
Yeah.
And so I would love to figure out how we can make a privacy system that behaves more like cash, where like everyday transaction, everything else is like really, really private and easy to do. Something that like moving $100 million by a single person or by a single entity is not as easy and requires maybe a bit more. What is a bit more is like still an open area of research, but this is like also where the word practical privacy comes in my mind. And so it's like practical and scalable privacy. Those are the 3 words that I would use to describe Miden.
Amazing. Since you already touched a little bit on this, this is something that you're really interested in exploring. What are like the roadmaps for Miden over the next few quarters? Is this like one of the problems you're going to tackle?
Yeah, so I mean, the first problem that we're tackling is just going to mainnet, and as I mentioned, this is hopefully this will happen, in a fairly near-term future. We're targeting either end of Q1 or more likely a beginning of Q2 next year. There is not a lot of time left. There's already end of the year right now, I think this is like the immediate concern, just getting the network running and operational. I think once that is done, like the next goal will be kind of working on the decentralization aspect. So how we can decentralize the network, how we can make the network more threat resistant. This is what I mentioned about the practical privacy, where what are the protocol level features that we need to research. And then the third goal, as I mentioned before, is like how do we make it more secure, like harden the proving system, harden the protocol, make sure there are no bugs. And this will not take just a couple of quarters. This will take, in my mind, again, 2 to 3 years at the very least. But this is going to be like the next challenge on the technical front. There will be challenges on the non-technical front, like making sure there is a thriving ecosystem. I didn't touch about like one of the aspects of Miden, which we want to make sure people can just come in and build on Miden as easily as possible. So we're using like Rust as a programming language. And so like making sure developing on Miden is easy, that using Miden is easy, people can build like applications very easily. This will be an ongoing thing that we will like, even at mainnet, I think we'll have a good experience, but like it will take time to like get it to like a best in class experience, I think. And so this would be the ongoing work on over the next couple quarters.
Got it. Thank you so much, Bobbin. I think that's the time we have together. I think we covered a lot. I definitely learned a lot. I hope our listeners as well. So yeah, guys, if you want to learn more, you can follow Miden on X or check out their website, miden.xyz. We'll drop the links in the description. And from our side, we're really proud to be supporting Miden as an infra partner. And if you're building in the space, you want to talk about infra proving and how to get something like this into production, reach out to us. And thank you again, and we will see you in the next episode.